Okay. So if this is how all equations work. If we just plug some numbers in, they give us numbers out. And then we can graph those points to sort of get a shape of the graph. So for this, I'm going to start with 1 right here because that's a little bit easier to plug in here. So if I do 2 to the first power, what do I get? No. 2 to the first power is 2. So that's, if I plug in 1, I get 2. If I do 2 to the second power, I'm going to get 4. So I'll get 4 right here. If I do 2 to the third power, what do I get? 8. Okay? Now, I did those first because we should know how to do those exponents. Technically, you should know how to do these other exponents, but I usually find kids have forgotten. What is 2 to the 0? It is 1. Very good. What is 2 to the negative 1? Not negative 2. It is 0.5. All right? Why? Other than, I mean, like, if you typed in Desmos, that's fine. We can use it on anything. But look at the pattern right here, because a lot of times kids don't understand why this 2 to the 0 is 1 either, which I agree with. It seems odd, right? It seems like it should be 0 maybe. But look at the pattern. If I go from 8 to 4, what would I have to do? Cut it in half. Divide by 2, right? And then 4 divided by 2 gives me 2, right? 2 divided by 2 gives me 1. So what do I need to do to get over here? Divide by 2. That's going to give me 1/2. Right? So negative exponents, you do a little bit of negative exponents in Math 1, I believe. Negative exponents, they get sent to the bottom of the fraction, which makes their exponent positive, and then the top just stays 1 right there. So you get 1/2 for that. All right, so if I graph these, I got negative 1 is my x-coordinate, 1/2 is my y-coordinate. I got 0, 1, I've got 1, 2, I've got 2, 8, so make sure you're, or 2, 4, I'm sorry, 2, 4. Ignore this point right here, it should be right here. Okay? I can definitely tell it looks like this side should look like this. It doesn't stop right here. Like I could plug in -2, -3, -4, -5. What's going to happen? Is it going to like cross the x-axis? What do you guys think? What happens? Somebody do 2 to the -5 for me. Do 2 to the -5. Do it, Desmos. Tell me what you're getting. 0, 3, 1, 2, 5. Or the 1, 0, 2 zeros. There. Okay, 0 point. Just say it for me again. 3, 1, 2, 5. So like, that's not 0, but it's so close to 0, it's probably going to look like 0 if we graph it. Is it ever going to go negative? What do you get? Like, do 2 to the -10 for me. So that still is not 0, right? It's still, like, it's going to look like it's touching the x-axis, but it's not really. It's a teensy bit above, right? So this is what an exponential function is going to look like, the general shape. Okay? You only got 0 because Desmos has to round to a certain extent. What negative exponent did you use to get 0? Okay, so negative 1,468 gave you 0 on Desmos. But what's really happening is not that it actually equals 0, it's that you have reached Desmos's limits of rounding. I think Desmos keeps 10 decimal places, so if you get past that, if it's like, it will still, like it's going to say it's 0, but it's just because it can't do more than 10 decimal places. It's rounding your number down to 0. So what's happening here is that you're getting closer and closer and closer and closer to that line, right? For this particular graph, the domain of an exponential is always all real numbers. Or we could say negative infinity to positive infinity. There. That's always the case. You can plug any number into an exponential. The range of an exponential is restricted. In this case, for this function, so for y equals 2 to the x, the range, what is my range? What's the lowest I go for this one? What's my lowest y value? I go lower though. Like on my table, it was 1/2, but I go lower on the graph over here. I'm going towards 0. I never get to 0, right? But I'm almost to 0. So much so that Desmos starts to say it's 0 after a certain point. How can I show that I mean 0 but not quite 0? If I'm doing like intervals right here. If I use that parentheses, that means 0 but not including 0, right? So that means all the way up to 0. That means 0.00000000001, or even closer, but it doesn't include 0. So the very lowest I go on this graph is 0, but I don't get there. What about the highest that I go on the graph? What's the highest the y values go? They go to infinity because this goes up forever on the right side. Okay, you will get questions on quiz or test that ask you what's the domain of this function, and it's going to be an exponential. You can automatically choose all real numbers. I would make sure that this statement right here is on my note card somewhere, because that will answer that question for you. If you have an exponential equation and it's asking for domain, it's going to be all real numbers. Okay. All right, so that graph, that exponential graph, has a horizontal asymptote. So I've used that word asymptote before in class, but let's explore exactly what that is a little bit deeper. So a horizontal asymptote is a line or curve that a function approaches. All exponential functions that we will look at in this course have horizontal asymptotes. And so what is happening here, the demonstration that I usually use for this, it's what was happening in that, like, y equals 2 to the x power. Let's say that I'm going to walk halfway to my cabinet over there, right? So from where I'm at right now, I'm going to walk halfway to that cabinet. So I'm going to end up about right here, okay? I'm then going to walk halfway to my cabinet again. So that would be about right here, right? I'm going to walk halfway to my cabinet again. So there are 1, 2, 3, 4 blocks in between me and the cabinet. I'm going to go over here, so I'm only 2 blocks away from the cabinet, right? So if I go halfway to my cabinet again, now I'm 2 blocks away. I need to move so I'm 1 block halfway to my cabinet again, am I going to reach the cabinet? Not if I'm a point, obviously, like I'm already touching the cabinet here as an actual person, but I'm only half a block away from the cabinet. And then a 4, and an 8, and a 16. If I walk halfway to the cabinet over and over and over and over again, do I actually ever make it to the cabinet? I do not, theoretically. Now, in real life, I am not a point, so I can't be a 16th of a block away from the cabinet. I will be touching the cabinet, right? But when we're talking about graphs, those are points that don't have any width to them. So that's what's happening over here for that horizontal asymptote. If we graph it on Desmos, if we graph something like, let's just graph that y equals 2 to the x that we just looked at. If I graph it on Desmos, it's going to look like it hits the line there, but if you zoom in, it does not, right? It's not touching the graph. And that would be the case all the way out, as you can zoom out far enough. That is a horizontal asymptote. You get closer and closer and closer, but you never theoretically touch it. Something very important for you guys to know right here. This is Math 1, but even my calculus kids get this mixed up sometimes. The equation of a horizontal line is given by y equals a number. Horizontal lines are going to be y equals a number. We're going to learn later, vertical lines are x equals a number, right? The reason that is, if I look at this graph right here, if I pick points on this graph, this point is the point 0, -3. This point right here is the point 6, -3. This point is the point -5, -3. Right here, I've got -8, -3. What's the same about all the points on that line? The -3, the y coordinate, right? So if I want to do the equation of this line, this is y equals -3. All the points on that line have the same y coordinate. Okay? You get to use Desmos on everything you do in here, so if you get confused about whether it's y equals or x equals for horizontal, just go over here and type it in. Y equals -3, y equals, x equals -3, and see which one it is. And hit the house button so you can see it. Y equals -3, the blue line, that's a horizontal line right there. X equals -3, that's vertical. I was aggravated with Hunter Hyatt the other day when we were looking through his Math 2 quiz that he missed because he could have used Desmos, and he picked the horizontal line when he should have used the vertical line, and he could have just typed it into Desmos to see which one was vertical or horizontal. So that's something that we need to know. One thing we are expected to know here is end behavior of a graph. So a lot of times we want to describe what's happening on the very ends of the graph for really big numbers. So to talk about end behavior, you're going to use the same pattern each time. As x approaches -infinity, y or f of x, depending on which one they use for the equation, approaches what? And as x approaches infinity, y or f of x approaches what? So this is what we're going to look at. When we see as x approaches -infinity, this is telling you to look at the left side of the graph. All right? Because negative infinity, if we're thinking about our x-axis, negative infinity is over there on that left side of the graph, right? Whenever we think about as x approaches positive infinity, right here, that positive infinity tells us to look at the right side. exponential equations, they're always going to have a horizontal asymptote. So when we're looking at what's happening on the end, we are either going to see it go up forever, down forever, or it might have a horizontal asymptote and it might even out at a number. Okay, so let's look at finding all these things. Okay, so I've got this graph here that's given to us. You can type it in Desmos if you want to look at it more closely. I need to find the domain, the range, the asymptote, and I need to talk about the end behavior. So you shouldn't even have to look past the equation. Oh, the equation right here to answer the first part. What's the domain of this exponential equation? I told you to put it on your note card. Negative infinity to positive infinity. Is it exponential? I don't even have to think about it. But if I do think about it, domain and range is the same as what we've done before. On the left side, this keeps on going to the left forever. On the right side, this keeps on going. It's going up, but it's also going to the right a little bit forever. So it's negative infinity to positive infinity. Yep, all real numbers is the same, so that's fine as well. Yep, you can use that or you can use all real numbers. Okay, for our range, now we're talking about our lowest number and our highest number. Okay, so what is the lowest we go on the y-axis here? Looks like -4 right there. If I kind of like draw a line on out, what does it look like is happening right there at -4? What do we have? That fancy A word. We have a horizontal asymptote, right? So at -4, we're getting closer and closer to -4, but we never actually reach it. So we want to use a parentheses, -4. We don't use a bracket because we're not including it. What's the highest I go on the y-axis? Positive infinity. This one goes up forever. Okay. For the asymptote of this graph, I need the equation of that blue dotted line right there. What's the equation of that line going to be? I think I heard it. What? Y equals -4. Okay. It's going to be y equals, that makes it a horizontal line, and that's going to be at -4. You can always type it in Desmos to make sure it looks right. Okay, when you're doing end behavior, as x approaches negative infinity, that tells me, right, as x approaches negative infinity, that's telling me left side. So if I start here in the middle, and I go towards the left side of the graph, what is my y doing? Is it going up forever, down forever, or leveling out at a number? Leveling out, right? What number is it leveling out at? -4. Okay? When I see as x approaches positive infinity, that tells me to look at the right side of the graph. All right? If I start here in the middle and I go towards the right side, am I going up forever, down forever, or leveling out at a number? Up forever, which would mean I need to put what right here? Positive infinity. Okay, questions? All right. Let's talk about some graphs of some logs. Okay, so I have chosen to use y equals log base 2 of x. Now, I also am having some second thoughts about how I did this right here. Would you guys agree that y equals 2 to the x and y equals log base 2 of x are inverses? Is that true? Like what we did yesterday? if I want to, like, get the inverse of this, I just log both sides. So I'd get log base 2 of x as my inverse. So I could make this table here. And I'm definitely going to have to use the calculator if I do. But if I have inverses, what are the differences in their tables? If I have two functions that are inverses, what is different about their tables? Or if I give you a table of something and ask you to give me the table of the inverse, what would you do? Flip the x and y's. So I could do what I did there. Or I could just take my table I made for this one, and I could just switch it. And I wish I had left this table blank so we could just do that. So I think that's what we're going to do. So if I just switch that table, pretend that I have left this blank. I should have. It'd be better notes if I had done that. So, like, I had my other table for y equals 2 to the x. I had negative 1, 0, 1, 2, 3. You guys can just look at your other slide there. But it was 1/2. It was 1, 2, 4, 8. So I could just switch my x and y's here. So I could say that 1/2 is negative 1. I could say that 1 is 0. I could say 2, 1, 4, 2, 8, 3. That'll be easier than what I had there. So if I graph those points at 1/2, I get negative 1. At 0, I get 1. 1, 2, 2, 1. 4, 2, 8, 3. Definitely this side is doing something like this. I wonder what's going to happen if I plug in smaller numbers. So somebody plug in 0 for me, like do log base 2 is 0. What do you get when you do log base 2 of 0? If you just go over to Desmos and type it in. It's undefined. What about like a negative number? Like try log base 2 of negative 4. Something like that. Negative 5, negative 10. Still undefined. I told us whenever we did this, we can't take logs of negative numbers or of 0. So I can't even plug in negative numbers. What about like a number smaller than 1/2? Like 1/2 is 0.5, right? Try doing log base 2 of 0.1 for me. Okay, so when you plugged in, I'm going to add this right here. When you plugged in 0.1, you got negative 3 point what? 321. So like negative 1/10, which is going to be really close, is like negative 3 point something, like right here. What would be a number even smaller than 0.1, but also not 0? 0.05, 0.01, either one of those would work. Somebody type in 0.01. Negative 6.64, so 0.01, that's practically on the line right there, right? So what's happening here is a logarithmic equation I don't know why I did that. Logarithmic equation is going to have a vertical asymptote. We're going to get closer and closer and closer and closer to, in this case, the y-axis, but it doesn't ever actually touch. All right, so the domain of a log function is going to be restricted. The range is always all real numbers. or negative infinity to infinity. Here is something you definitely want to include on your note card, because I'm going to ask you a range question, and it's going to be of a log function. What should your answer automatically be if we're talking about a log function? Should automatically be all real numbers, right? Okay. Now, for this particular one, the domain for this one here, what would it be? What's the very furthest to the left I go on this graph? What's the very furthest left? Ignore this weird line that it put up there. It actually is just right here. What's the very furthest left that I go? What is the very furthest left that this graph right here goes? Okay, it doesn't go all the way to the y-axis. What's your x-coordinate on that? Right on that point. X-coordinate. X-coordinate right there is 0, right? So the very lowest or very furthest left you go is at 0. Okay? What about furthest to the right? What's the furthest to the right that you go? That's infinity, because you keep on going forever in the right direction. Okay, that would be the domain for this particular function. Okay, domain will always be restricted for these. Okay, questions? All right, these are going to have vertical asymptotes. So we've already talked about asymptote sum. All log functions that we will look at in this course have vertical asymptotes. Sometimes it's a little hard to see from the graph, but they always have vertical asymptotes. And the equation of a, oh, that should say vertical right there, not horizontal. It's a typo. The equation of a vertical line is given by x equals a number. Okay, so like if I look at this vertical asymptote right here, what is the equation of that vertical asymptote? Anyone? X equals -2. Okay, and the reason for that is your x-coordinate of all those points is -2. You got -2, 7 right here. You got -2, 0 right here. You've got -2, -3 right here. Like every point on that line has an x-coordinate of -2, right? So, try that log equation right there. Try to answer domain, range, the equation of your asymptote, and your end behavior. Oh, well, end behavior is going to be a little tricky. Do the first 3. You can try end behavior if you want. It's a little trickier on the log function. So everybody try it on your own. First of all, you're looking at the y-axis, which would be wrong. You want to be thinking about x-axis. So, like, this is the one vertical axis, right? So we're thinking about the x-coordinate at that point. Looks like it's probably 1. Right, so 1 one's the furthest left it goes. That'd be your first number, not negative equal to domain. Alright, what's the furthest to the right that you go? But you might have to have. What is this? Definitely a double zero. Alright, check with your neighbor. See if they're getting the same thing as you. You get the same thing as me? Alright, let's look at what we've got. Alright. Okay. We're looking at a log function. This is natural log of x minus 1 plus 3. Let's talk about range first. Heston, what's the range on this one? Range. Good. Negative infinity to infinity. I asked that one first because it's the easiest. It's always going to be the answer for a log function. Sometimes it doesn't look like it when you graph it. Like if I graph this one, I've got natural log of x minus 1 plus 3. Be careful, like if you zoom out, this looks like it has a horizontal asymptote. Logs don't have horizontal asymptotes. That is still going up a little. Also, when you zoom out on Desmos, logs are going to look like they stop. They don't really. Desmos has just ran out of numbers right there. It can't go any further. Also, sometimes you just get like these weird breaks in the graph. That is just a limitation on Desmos. In reality, that line just keeps on going down forever. Okay, for that. So your range is always negative infinity to positive infinity for a log function. Hector, what did you get for domain? Okay, 1 to positive infinity. I like that. That looks good. This particular graph has a horizontal asymptote. Richard, what did you get for the horizontal asymptote? Oh, I'm sorry, I said that backwards. This particular graph has a vertical asymptote. What did you get for the vertical asymptote on this graph? So we're looking at like a vertical line where this graph just never passes it. Right? If I draw it in over here, it's right here, and it is at 1. Is it x equals 1 or is it y equals 1? It's x equals 1 for your asymptote. X equals is going to be the vertical line. Okay. End behavior is a little bit trickier with logs because normally we do as x approaches negative infinity for the left side and as x approaches positive infinity for the right side. But does this graph approach negative infinity? It stops right here at 1. It never goes below 1, right? So for my left side, I don't want to say as x approaches negative infinity. What we can do for this is it's as x approaches the left side of the domain. So if I look at my left side of the domain, this number right here, that's the number that goes here. Okay, so as x approaches 1, because we don't go past 1, we don't go to 0, we don't go to negative 10, we don't go to negative 1,000, negative 1,000,000. So but this still means left side, so it's the left side of my domain. So if I sort of start in the middle here, and I go to the left, do I go up forever, down forever, or level out at a number? down forever, that means I should put negative infinity right here. Okay? As x approaches positive infinity, y approaches blank. So positive infinity, as I go to the right forever, do I go up forever, down forever, or level out at a number? It's up. It kind of looks like it levels out at a number. But remember, we just said logs don't have horizontal asymptotes. So even though it's just barely going up, it is going up for that. Okay? Questions? Okay. Exponential functions. We have to look at these. We're going to look at some information about the standard form here. So you do this in Math 1. Exponentials are used for a lot of different real-world things, and we'll look at a few of those in our last section of this unit. But it's going to be y equals a times b to the x power. A is your initial value, okay? That means that initial value is going to be what your y value is whenever x equals 0, right? It is also going to be the y-intercept on the graph. B is your growth or decay factor, and your x typically is some sort of time. It may vary in what type of time. It might be your months, days, years. It could be like a increment of time that is not a specific time, like the number of rounds in a tournament. Like, it might not be specific days, but like whenever the NCAA tournament happens, you start with 64 teams, then there's only half of that. That's an exponential equation, although the time frame is the number of rounds, not a certain number of days for that. So, this growth or decay factor, if you have growth, you are going to do B equals 1 plus your rate as a decimal. So this would be things like if you put your money in a savings account, right, and you get 2% interest, then you got your B value would be 1 plus 0.02, right? If you have decay, if what you're looking at is decaying, your B value equals 1 minus your rate as a decimal. So, like, you go buy a car. As soon as you drive that car on the lot, off the lot, what happens to the value of that car? Down, right? So you're losing like a certain percentage of that. So you would do 1 minus. If your car is losing like 15% per year, it'd be 1 minus 0.15, right? So if I have growth, what's going to be true about this B value right here? It's going to be not just positive, but it's going to be bigger than what? A certain number. What number? It's bigger than 0, but there's another number. It's bigger than 1 because you're doing 1 plus the rate, right? So it's got to be bigger than 1. So for growth, B is greater than 1. For decay, B is going to be less than 1, but specifically it's going to be between 0 and 1. It can't be below 0 or it's negative and then weird things start happening. You can't, like if you buy a car and it's losing money, it can't be worth like less than 0, right? Like it's going to stop at 0. You might have a worthless vehicle, but you don't have something that's worth negative money to you. There. So, exponential growth is going to look like this. Again, this is if B is greater than 1. You have exponential growth. Exponential decay is going to happen if you have your B value is between 0 and 1 here. Okay, so we can tell whether we've got growth or decay just by looking at our equation. So, for each one of these, without graphing them, decide if it's growth or decay. So write growth or decay next to each one. Okay, check with your neighbor, see if they think the same thing. All right. Sophia, what have you got for A? Is that growth or decay? Okay. Which number is like the B value, the one that's being raised to the power? Is it the 100 or is it the 0.12? It's the 0.12. This is your B value. If B is bigger than 1, you have growth. If it's between 0 and 1, you have decay. So 0.12, is that bigger than 1? No. So this one's decay. Okay? Joey, how about B? That is growth. You're looking at just this number. The first number is a decimal. That's your initial value. You're looking at whether or not that number inside that's being raised to the x is bigger than 1. 5 is definitely bigger than 1. Cannon, how about C? That's decay. Because 1/2 is between 0 and 1. Right, it's not greater than 1. Okay, questions? All right. We're getting close to running out of time. So rather than giving you the card sort that I was going to give you for your assignment tonight is going to be to finish this last slide. Okay? We still got a few more minutes, so don't pack up on me yet. You can graph these on Desmos to see them. Okay? When it says EB right here, that means in behavior. And you will need to have, like, you'll be like as, you can write it shorthand like this instead of writing as x approaches. You could do as x and then do an arrow, negative infinity, and positive infinity or whatever there. So your assignment tonight, rather than the card sort that we were going to do, is for you to finish up this right here. So you need to try to get at least one of them done before you go. I'll be around to help if you're stuck on something. You can graph those on Desmos. And then what you don't get done, you want to finish up for me. Okay?